So I'm Greg Matthews over at NASA Ames. The unwritten subtitle of this presentation is Greg's Chance to Influence the Roadmap Discussion at 1:45. So we'll see what we can do with that. So NAS is where I work. I'm in the building where PBS actually was originally developed. So I get some fun history with that. And here's the context for my presentation. So we were using PBS Pro to handle quite a few nodes over at NASA. The biggest instance we have is it actually operates with a single PBS server. A couple of our primary clusters. Pleiades was shown earlier in a slide, I think by Joe, and that is currently in the decline mode. So there's an odd number of nodes there because we're starting to cannibalize things to keep things running. The future, it turns out for us, is to place new clusters inside of containers out in the backyard. So we're starting to do that. Electra is our first test for that. And then in general, when we're doing our scheduling, we are doing things with one job on a node at a time, exclusive access. So that's going to color a lot of the features that we have asked for, things that we are driving towards. And we like to try as much as possible to keep in mind that there are folks sharing their nodes. NCI is a good example of that. You guys have extreme sharing going on. And so as we work with Altair on these features, we're trying to make them as generally applicable as we can. And again, to the idea of job mix here, so I smile a lot as I watch Roger's presentation because you can take a lot of the numbers and letters and scramble them, and they're kind of the same for NASA. So we've got a gigantic number of users, not as gigantic as them. That we have the novice to the hero range of users. We have no control over applications for the most part. Whatever they bring is what they run. And then we are heavily oversubscribed. So there's always a very heavy emphasis on who is important, what is priority. And so we do our own prioritization, much as NCI does. And then we even have a system that I've presented at previously what we call resizable queues. We'll take queues and assign nodes to them and then change that assignment dynamically using these system jobs, as I mentioned on the slide. And a couple of smaller clusters as well. We've taken some of the old hardware from Pleiades, moved it across campus, and we call it Meropa. So it's out there. And we have a couple of SGI UV machines. So let's dive into the features that we are working with Altair on. This one is actually in production already at NAS. If you want some more of the sort of background of what Altair is doing to make it official for everybody else to use as well, you can go to community.pbspro.org and look for that identifier there, PP389. And the background here is that we've been using the suspend jobs feature for a few years, entirely not what it was designed for, entirely not what the general purpose is. So we use it to suspend the entire cluster, bring the whole thing down with a sig stop, nice, giant, branched out sig stop, make everything nice and quiet, and then do mean things underneath the job without it knowing. So we'll go out there and we will do Lustre server upgrades across all our file systems. We will do massive changes to our interconnect. And job has no idea because it stopped. Everything's fine as far as it can tell. And we have a lot of emphasis on our cluster also of bringing in new racks to sort of accrete onto Pleiades. And then we've also taken things away. And it turns out you can add easily without having to do the suspend process. Removing, not so much. When you do that, you're going to change a lot of things from the view of the subnet manager and InfiniBand, and everything else can go kablooey. So we suspend all the jobs. They have no idea that a bunch of nodes just disappeared because they weren't running on them. And we can proceed on from there without having to actually drain anything to accomplish that. So it's really, really excellent for that purpose. Saved us many, many compute hours to do that process. Now again, the suspend process that's available, the qsig suspend, is not meant for this. It's really meant for freeing resources, making things available for others to run. And so as we got more use of this over the years, we came back to Altair and said, okay, it's really great. We're really enjoying the savings of time. but we want to actually get sort of the feature we want, which is system maintenance suspend. So Altair went off and worked on that with us. We had a couple prototypes, and now we've arrived what we have in production. So you can use, in our build of it, a couple of new pseudo signals to the qsig command. You can now say admin-suspend and admin-resume. And the beauty of this is it will actually put the nodes, the job that you are targeting, into a new state called maintenance. And the wonderful thing then is, as the PBS admin, bring the system back up after all your colleagues have spent time ruining things in Luster World and everything else. I mean, making them better. Is that now when you go back to actually start jobs, instead of having to fight the scheduler and fight the server, because they really want to start sort of new work on all these free resources that are out there under the standard suspend, now what they can do is they say, all right, all these maintenance state nodes are unavailable, so now things that are truly free we can start new work on. So it's a much more graceful process to get work back on the cluster. And then if you've done enough of this as an admin, you will know that after these activities, usually you have some fallout. You know, some number of nodes that decided they didn't want to play nice anymore with what your changes were, drop into KDB, all kinds of fun stuff. And so the scheduler and server can really have a lot of heartache trying to start jobs back, or sort of resume jobs on those nodes that have fallen apart. So now, with this process, we can bypass a lot of that. We can tell the server, I don't care what state the thing is in, just resume the job. And then the server will decide, oh, that node is down, job must be dead, cleans up, everything runs beautifully. So now we've got a way for that poor PBS admin at 3 in the morning to start just typing away commands to get jobs back up again and start new work without having to fidget with everything and mangle the scheduler into what it should do. So that's suspend jobs for system maintenance. Node ramp down. Couple of IDs there, again, for that website for community discussion. We're just using this in production as of a week ago, Monday. It's only caused the PBS server to core dump 3 times so far. I didn't tell Bill that one ahead of time, but I did patch that one already. So we're patched, we're good. I'll get that feedback to Altair pretty soon. But this introduces a new command for users to use called PBS Release Nodes. Fairly straightforward. You give it job ID, and then you can give it nodes that it should actually just release from the job. And the PBS server will happily do that. So you can shrink your job as you're going. The sort of genesis for this, for us, was that we have a certain class of users who have sort of the worker task model jobs. So they'll go out and they'll get maybe a handful of nodes, maybe 100 nodes, and then they'll do their own scheduling, right? They'll form things out to them, maybe use a GNU parallel approach, other types of sort of user-level scheduling. But the problem was that they'd always have in that set of work some long-tail job. So it would be like a 5-day job. Most of the work was done in the first day, and then they had one more guy that was left running for 5 days. And so all these idle nodes are tied up running this job, doing nothing. It'd be really nice to actually release those back for others to make use of. So Altair has gone off, implemented this for us, and it actually works very well now that it's patched. And they are working towards making this available for everybody else also. So you can check that out on the website. I've been sort of making the pitch to our users that they should actually consider more broad applications of this, because in, again, a very oversubscribed system, a place where when you get your chance to run, you want to just kind of get as much done as you can. For those that don't have enough allocation to sort of deal with that idle node problem, they've already taken their job and split it into the right size pieces. So they have several jobs to run. The first one might wait for 3 days. The next one will wait for a week after that. Now let's just merge that work together. Make it one job, pay the wait once, and then go off and shrink the job down to what it needs to be. So that can be a really useful thing. Things we had to overcome in the implementation, Altair has done a great job knocking these out. The PBS node file, that file that the job has on the head node, does get updated when you release nodes, so you can actually go out and run, MPI exec, et cetera, after you release nodes, and it should do the right thing. And then the server is very tolerant of the nodes that have been released, perhaps not checking back in the way you'd like them to. They might have some fidgety problem there. And so the job won't notice that. It'll just know it's shrunk, and off you go. And then the PBS server will deal with all of those troublesome nodes separately and get that out of the way of the user. And a couple more things that are good about this. They added a feature for those who are doing stage out at the end of the job. You can actually have the server aware of that, and then mom made aware of that, and so it will shrink the job for you when it begins stage out. So all those nodes waiting around for an hour for those files to move don't have to be idle doing that. They can go back and do useful work. And of course, job accounting has a new record to deal with updates to the job. So we kind of go a little further with this concept of messing around with the size of the job. We have a feature we call Reliable Job Startup. This one we have one prototype that we've used so far, and it's back in Altair's court. They're going to work on it some more. This I'd like to call the way for the HPC admin to express their level of confidence in their cluster that day, that week. So certainly there are times where I'll look around at the landscape of user tickets coming in, of the work being done by my colleagues, and I can tell you Pbs is not happy today. Your job will not start the first time, most likely, if it's above a certain size, et cetera, et cetera. And so with that knowledge, what we've said to Altair is it'd be really nice to have sort of a knob that I can indicate my confidence in the cluster. And that knob, what we're working towards is a QJob hook to express how many more nodes it would be good to actually give this job to give it a chance to start beyond what they have asked for. So the example here is the user asked for 10. I have a 20% lack of confidence in the cluster, so I say we'll give you 12 instead. And then that, since it's just a pile of Python you've written, you can make it as fancy as you want for whatever time frame. The scheduler will go off, make the 12 nodes available for the job, and now there's smarts put into the head node of that job where it understands what the user really wants, what it's been given, and then it goes off, and really what we're sort of selecting from is every node that is successful in passing all those pre-job checks, right? The prologue and the hooks that you've written. And so as long as you get 10 out of 12 that are good, that job can go on and start. And so now we've made job startup more reliable. Yay! And then you also can do various actions with those that didn't actually succeed in making it to the start. So there's ways to go off there and offline or deal with those nodes. And again, this really gets back into, I think for us with heavily oversubscribed systems, it's that window of opportunity that user has when that job starts. It is very, very precious because their colleague, who is more important that day, could put the job in just after they get their chance. And if their job fails to start, their colleague gets to start, and there's inter-office rivalry and warfare and all kinds of bad stuff happens. So we want to make sure we get that job to start when it has a chance. And then beyond the fact that they may have waited 1+ days, and the plus can be pretty heavy here. We can be waiting for 10 days, 11 days, 12 days for your job to start. And so when I see the tickets come in where someone says, I just waited N days and my job ran for a minute and then it failed, I can imagine there's some amount of shock going on, and the users can sort of like write the ticket in this frame of like, I don't think it's my fault, I think it's your fault. And so we go off and look at the system and try and figure things out. But hey, wait 10 days and it doesn't work, that can be a bummer. And then the other sort of general use case for this is that as, again, the PBS administrator, there are times where people come in and say, I want 1,000 nodes, 2,000 nodes, some gigantic pile of nodes to run a job. And we go, okay, we can do that. We might set a reservation up. We might do something special for you. But when I do that, something special, I almost always tack on more because I know we're going to have some fallout. I won't have complete confidence that the job will start on that first opportunity. So now I can do that programmatically, which is great. Just automate the thing. And then again, the whole notion of what can be a problem for the cluster, they can be very, very bursty. So we certainly go through times where we put in some new client version of Lustre and it has problems for some reason. We might have the bad DIM gremlins that spread out and cause issues. So whatever our pre-job checks are able to catch, we might see waves of problems with that, and this feature gets us there. So let's go even one step further with the notion of the reliable job startup. So we're just in the sort of idea phase with this one. And if you want to throw questions at me after this talk or even any time later, I'd be happy to kick around some thoughts on this one. So back to that user that asked for the big pile of nodes, they will say, I'm going to run a job on 2,000 nodes. What they really mean is I have a set of jobs to run. I don't know how many. I don't even know what size, but I need a lot of nodes to start with at least. And so I will go through that sort of thought process when that request comes in to understand what they really need and then dive into it. Can we automate that process? Can we make that even nicer, again, for the admin side and for the user? So example of this can be a scaling study. Someone might say that I want to run 2,000 nodes as sort of the max case, and I'll ramp up to that point. But if you look at it, sort of a scaling study, usually in our environment at least, the users don't have a notion of making the one script that does everything. It's not going to be one job. It's going to be typically multiple jobs. It's going to be done in different scripts because that's the sort of containment unit that they're used to. And so this kind of gives you this sort of partly defined set of jobs. They're going to submit more of the 600 nodes because it failed the first few times, fewer of the next size, et cetera. You could potentially push back and say that we want to do this as one large interactive job, and you can just do whatever you want within that. But you are vulnerable in that case. If what they're doing is just too mean and then they take a node out or something, the job itself can go away. And you're back to where you were, having to potentially drain the nodes again to get that user started. So one idea is, can we make jobs extremely fault tolerant? Can we simply say, it doesn't matter what happens to this job, let it run, let it continue, the user will work around that possibility. And then we can look at reservations. Are they really the right answer for this? They put here on the slide that could work, but they, at least in an oversubscribed, highly priority bound system, reservations are entirely a cheat code. That's just a way to get around everybody who is in line ahead of you. So that won't work very well. But we could potentially change reservations so that they follow more of the priority structure. An idea. My colleague Dale was thinking about the idea of inheritance. Maybe we can actually have jobs that will indicate, hey, when I'm done, this other job should get my resources, so you can sort of pass the inheritance down the line to your kids. That potentially can work. Makes things kind of interesting. Why do you put limits on that? How do you control that? And then we can go pie in the sky stuff and start having entire new schedulers spun up inside of reservations that do the right thing, and you have policies that tell you when to release things. Lots of possibilities there. So again, I would love to get thoughts on there, or if others have done things to solve this already, to hear about that. Now, a different area of oversubscription. So we've got a set of front-end nodes, login nodes, and I think a lot of sites have the same problem we do, which is they are themselves too busy. Users are fighting over them, using too much memory. So we've done various C groups things, lots of ways to try and tame the population of users on those nodes. But as you think about it, they start looking more and more like compute nodes that can be managed by PBS. So I have the hammer, I have those nails popping up, and so why don't we go ahead and do that? And so we started moving towards this, putting our own effort into a prototype where we can start offering the compute nodes to function as front ends with the behaviors of front ends. And that's two main properties, I would say. One is that you can just get to the node directly without having to use PBS. So SSHN, whatever your access model is, offer that. And for us, this is sort of an interesting part of the feature because we're using an exclusive access piece, and we're using the restrict user directive for the PBS mom to kill off anybody that might log in. So we have to defeat that, or we have to change that, right, to be able to allow users to get to the node. And then if we do this, and we're trying to do this towards a sort of reservation type model, then the user can use that front end they have and submit jobs to it as well. So they can do a lot of their potential development work, making sure their scripts do what they're supposed to do on this front end node that belongs to them. And they can have it for weeks, months, whatever the time frame is that user could have access to a front end, could be years. We can give them that. So we're working towards that. And that can save us having to grow the front end pool. They have to live in their own rack typically. They're different in various ways. Why not have them be on compute nodes? And actually, why not just use compute nodes and offer those to the users as front ends? All right, we'll switch gears here. So back into the more firm admin side. How fast is my cycle? How is the PBS performing area? So we have a feature that we're calling a scheduler node buckets. And this one, we just received the second prototype, courtesy of Brome from Altair. So I read the email Friday. I haven't gotten to actually test it yet. But the story here is we've got a scheduling cycle that runs somewhere between 2 to 3 minutes currently. It can be down as low as a minute at times, but why can't it be faster? I'm the customer. I can ask that, can't I? So we actually put together at NAS a design for what scheduler could do to aggregate the different nodes that are out there and available on the system. We call them buckets, and for our combined cluster there with 12,000 plus nodes, we have about 50 buckets, and each bucket is described. The list of properties here: architecture, memory, queue, etc. And so 50 is a lot smaller than 12,700, or 12,400. And so we did that. Altair put the implementation together. We tested it, and it is very fast RISC. So the overall improvement was 10 to 15x. And so we had an example set of jobs and nodes that we could just kind of test over and over again, right? The same scenario. It went from 90 seconds down to less than 10 seconds. And really, it's more impressive than that because it turns out that maybe half of that 10 seconds is just the scheduler and server talking to each other, doing the things that they've agreed to do. So the actual piece of the scheduler that we sped up ended up being over 100 times faster than what it was previously. So where's our asterisk apply? So this was the quick and dirty. Is this crazy idea that NAS has even useful to do at all? So we told Altair, just cut all the corners, make sure it does the bulk of the scheduling work. So we do lots of things that are not applicable to node sharing, as I mentioned earlier, reservation jobs, etc. So queue limits, server limits, all optional. Let's just get to the meat of what it does. And so that proof of concept was wildly successful, and now we're going to demand that the actual product we get will be just as fast, if not faster, and it's going to be excellent. This one is not present on the community site. Probably would be good to have that at some point, but we are definitely working towards that. I think this is my last slide of import. So on the site, there's a discussion going on for making a richer, more complicated, more useful queue sub. And the way to generally summarize this, as Altair often does, is we make the scheduler faster, so now it's time to burn it again with some more things to slow it down. So Altair is looking at a number of different ways to offer more complicated queue subs to get what you really want, so the scheduler knows what to really offer you. In this particular discussion that we're going on with, there's the idea of conditional operators to allow you to really get into the meat of what resources you want to use. And one way to look at it, what we have right now with the existing queue sub is you can ask for, I want this or greater. That's effectively what you can ask for. Memory, this or greater. Number of CPUs, this or greater for the exclusive access model. We at NAS really want to get down into actually picking sort of sub-ranges, subsets of what's out there. Part of that feeds into the whole accounting notion. We have different classes of nodes that cost more or cost less for the user. If they know they can fit on the cost less nodes, then they can go off and actually maybe ask for that with this feature. The definite downside here, possible downside, is that if you're parsing the select statement right now in your hooks, it could get a lot harder to deal with. So how we go through that is part of the discussion. So if you're interested, please join that, and there are some ideas in there. And there's definitely other ways to do it beyond a really complicated select statement. There's possible doing a multi-dimensional place equal, group equal specification. We kind of use something that's similar to that right now in terms of how we place jobs on Pleiades versus Electra. So there's ways to do that, but the notion of making QSub more rich, I think, is an important one to get to. All right, that was it.
Cool. Questions?
The first two things that you talked about, the node ramped down and the reliable job startup,
Yep.
Sort of seems to have some bordering with features that are supposed to be available with PMIX, the MPI for exascale.
Oh, okay, okay.
Are you guys looking at that?
We certainly would want to sort of marry the two if that was something that our user base was ready for. So the whole notion of sort of like adding, subtracting, swapping in nodes, right, is becoming more and more important as all these things grow and as the fragility increases. So all of that will be on the table. So like our approach for doing the GNU Parallel example I mentioned, so I was going to go in there basically and add a feature to GNU Parallel myself so that it would know when its set of hosts of free hosts is known, just kick off a command to do that. And hopefully GNU would pick it up and we could move forward with that.
So on the node ramp down, which I think is pretty cool, what about a ramp up? So do you have jobs that need more nodes or a different type of node at the end?
Right.
So we've got some that are like that, and so we have people basically running kind of a job that launches another job, so that they get the big memory node at the beginning of the job, but they only need it at the end.
Right. So we didn't ask for that because we can't use it. But if you have a cluster that it's not oversubscribed, that absolutely makes sense, right? If it's going to be available or the user doesn't care how long it takes to wait. So in the discussion that's going on for this one, Bill has made sure to direct that whatever we do should not exclude the possibility of increasing job sizes on the fly. So.
Okay, last question here, and then we'll take a break.
So I have a question about you saying that you allowing users to SSH into nodes directly.
Yep.
At what circumstance you want to do that, and how would you know the user won't vandalize the node? Like, okay, they started realizing the advantage of using that, and then,
Right.
like what kind of restriction or recommendation you would control in this situation?
Okay. So for that feature, that's the sort of front end scheduling, right? So we're going to basically take compute nodes that right now only do jobs, right? Only do that kind of workload, and we're going to say that a user can create effectively a reservation for a node, and then it belongs to them. They can use that node just as they would have in a job script, and they can also use it just as they would have if they were on the front end, right, where they submit the job from. And so whatever that set of allowable activities is, they can do that on that node. And so SSHing into the node makes sense for some set of that use case. All right.
Okay, thank you very much.